So for 32, we have to sketch the region, interpret the area, and then evaluate the integral. So we're going to do it in a multi-step process where first we'll draw each curve, we'll then add it, take the absolute value, and finally we will integrate it. So let us draw the function. First we'll begin with 3 to the power of x. And it goes from 1 to -1 to -1, yeah. And then we have here 1, 2, and maybe I will draw it a little bit bigger, 3, -1, and -2. So 3 to the power of x, we'll draw this one first here. At x equals 0, we're at 1, because anything to the power of 0 is 1. At x is equal to -1, we are at 1/3, so roughly here. And at x equals 1, we are at 3. So within the domain, it is a curve that goes something like this. And this is y is equal to 3 to the power of x. Now let's do y is equal to -2 to the power of x. So it's 2 to the power of x, but then it's flipped upside down, so reflected across the x-axis. So at x equals 0, we would have 1, but then it's reflected, so we're at -1. At x is equal to 1, we are at -2. And at x equals to -1, we are at -1/2. So it goes something like this. Y is equal to -2 to the power of x. So let's add these up. At -1, we have -1/2 plus 1/3. So we're going to have -1/6 about here. At 0, we have +1 and -1. So when we add them, we get 0. And at 1, we have 3 and -2. So when we add them, we have 1. So it's a curve that goes something like this in our domain. And actually, let me draw that a little bit thinner so we can really see the area between the curves. So it's a curve that goes like so. Yeah. So this green line is y is equal to 3 to the power of x minus 2 to the power of x. So we have to look at the area. So the integral is the area beneath the curve, right? However, it's the absolute value. So what I'm actually going to do is I'm going to erase the other functions just so that we have enough space to look at everything. And so we need the absolute value, right? And the definition of the absolute value is absolute value of x is equals to x if x is greater than 0, or -x if x is less than 0, right? So from between -1 to 0, because the image is negative, we are just going to reflect it when we take the absolute value. So really, our curve is going to look like, maybe I'm going to do this in a different color. Yeah, in light blue, we're going to reflect this one. So it goes here, and then on the green part, because it is positive, so the absolute value of a positive function is just the function itself. So we're going to go here, yeah. So this blue curve, y is equal to the absolute value of 3 to the x minus 2 to the power of x. And we can see here, I'll just draw this green curve by its side just so that we can see what the original curve is. Yeah. So now we have to find the area beneath this curve, the absolute value curve, and the area is just this chunk over here plus this chunk over here. So to set up the integral, we will have to break it up into two parts because it's two different functions, right? From -1 to 0, it is the absolute value, so minus, because it does fit in this definition over here. And then from 0 to 1, it is the positive function. So let us break this down into two parts. So from -1 to 0, we do have the function, we're going to go minus, so minus 3x, then plus 2x dx, to the power of x. And then from 0 to 1, we do have just the original function itself. So just 3 to the power of x minus 2 to the power of x, and then dx, right? So all I did was I switched the signs because of the absolute value definition. It's negative if the function is negative, and it's positive if the function is positive. So let us just erase this, and all we have to do now is just integrate it, right? So the way that I like to integrate the exponential functions is I like to switch the form. So minus 3 to the x is really equal to e minus e to the ln of 3 times x. We're just changing it to the exponential form because e to the ln, they cancel out, right? And 2 to the x is just e to the ln 2 times x. And because we know how to integrate the exponential function, base e, this will make it much easier. So all we're going to do is we're going to rewrite this. So this is the integral from -1 to 0 of minus e to the ln 3 times x plus e to the ln 2 times x, right? And all of this dx, and then plus the integral from 0 to 1 of e to the ln 3 times x minus e to the ln 2 times x, and all of this times dx. All right, so we are ready to integrate it. So when we integrate this, this is just minus e to the ln 3 times x divided by ln 3, because the integral of a function base e is just the function base e itself divided by whatever is multiplying in the argument, so a reverse chain rule, and then plus e to the ln 2 times x over ln 2, all this from -1 to 0, plus e to the ln 3 times x over ln 3, minus e to the ln 2 times x over ln 2 from 0 to 1. And now all we have to do is we have to plug in our boundaries. So we first plug in 0, right? So this is just minus 3 to the power of 0 over ln 3 plus 2 to the power of 0 over ln 2, and then minus, so plus 3 to the -1 over ln 3, and then minus 2 to the -1 over ln 2. And then for this integral on the right, we do have plus 3 to the 1 over ln 3 minus e to the 1, oops, not e, I meant 2, minus 2 to the 1 over ln 2, and then minus 3 to the 0 over ln 3, and then minus plus 2 to the 0 over ln 2. So let's see if we can simplify this. So what we're going to do is we're going to join up everything with ln 3 and everything with ln 2. So I have 1 over ln 3 times, let's see, times this one, times 3. Let's see what else has L in 3. 3, and then we have minus 3 to the power of 0, minus 3 to the power of 0. 3 to the power of 0 is just 1, so minus 2, and then we have, let's see what else, we have this one over here, plus 1 over 3, right? So let us just kind of cancel these so that we keep track of what we've written, and then plus 1 over ln 2, let's see. We begin with here, so this is minus 2, and then we have plus 2 to the power of 0, so plus minus, let's see, minus 2, 2 to the power of 1, plus 2, and then we do have, because our plus 2 comes from here and here, and then we do have minus 1/2. So when we simplify this, we have, this is 3 minus 2, so 1 plus 1/3, so this is 4 over 3 ln 3, and then let's see, this is minus 2 plus 2, which is 0, minus 1/2, so minus 1 over 2 ln 2. Yeah, and this is our answer for this area over here. So this one was quite long and cumbersome because we did have to draw it part by part and then kind of flip over the negative side and then break up the integral into 2 parts. So I think that the most important part to remember here really is applying the definition of the absolute value correctly. So whenever you have an absolute value, just remember to apply this. X if x is greater than 0, and minus x if x is less than 0, which is what we did when we broke down the integral into 2 parts. As you can see over here, we said this was like minus the function, and over here this was plus the function. So that is our answer.